So I've had people get confused with this before, and one thing uh, they don't like is when you're using a z-score table and you want to find the probability of a z-score being less than or equal to say -1. Okay, and people get worried about, well, what about the equal to? I mean, why how can we can just ignore the equal to and just use the less than part of it? Well, what I've done here is I've taken some screenshots of this applet, and what I did is I said, okay, I want to estimate. I'm going to show you how, as we get closer and closer to just finding the area at -1, how that area is going to go to 0. So what I did to start here is I said mean is 0 and standard deviation of 1. And so what's the probability of getting exactly something that has a z-score of 1, not less than or greater than, but just, so maybe I better write that. What's the probability of getting a z equal to -1? That's what we're trying to do. And I said in one of the forums, discussion forums, well, that probability is equal to 0, and we'll see that. So I'm finding the area between negative z equals -1.1 and -1, and that's that skinny little line. And the applet's telling me that, oh, that's about a 0.023 or 2.3% chance of having whatever I'm measuring fall in that range from -0.1 to +0.1. What I did is I changed it, instead of -0.01, I shrunk it up a little bit and only made it be 5/100ths wide. And notice the probability is getting smaller. And again, I set it up so now it's only 1/100th away. And that line's getting pretty skinny looking, so there's not a whole lot of area there. And notice that area is shrinking right up, getting smaller. In this, it's only 1/1000th away from -1. The graph can't even show us that because the resolution is not good enough on the screen. And notice that area is getting even smaller. And now I'm 1/10,000th away. So, and what I'm hoping to get, and see that the calculator can't even calculate that probability. It's error. So what I'm hoping I've convinced you by looking at these shrinking areas that the probability of getting a z-score, or it could be even if it was the non-standard normal distribution, of getting a number that's exactly that one number is 0. Okay, so I hope that helps. So it's that one problem that we looked at in the discussion forum for week 8, where there was a binomial approximation or normal approximation of a binomial theorem. The first question says, what's the probability of getting exactly 1? Well, or exactly whatever it was. If we're using the normal distribution, that probability is going to be 0. Otherwise, we're going to use the binomial distribution.